Welcome back. This is JMA Tips. Today we are going to be solving this indicial equation. We have here 9 to the power x minus 4 into 3 to the power x plus 1 plus 27 all equal to 0. So to solve this problem, we are going to write this number here in exponential form with the base 3. So we are going to have 3 raised to power 2 all raised to power x minus 4, and this very one here we are going to write 4 times because this is same as 4 times everything here. So we have 3 raised to power x times same 3 raised to power 1, this one, plus 27 all equal to 0. From your indices, we all know that a raised to power m all raised to power n is the same thing as a raised to power n all raised to power m. So we are going to use this to transform this expression here. We are going to use this to transform this expression. So I will write this as 3 raised to power x all raised to power 2. What you have here is the same. You get? So also the reason for this, from here, from your indices, we learned that a raised to power m plus n is the same as a raised to power m times a raised to power n. So what you have here is this, and this very one here is the transformation here. Okay, so to get an equation that is easier to solve, we are going to substitute the value of t, or let me first of all simplify this. We have 4 and 3 here, so this times this will give us 12 times 3 raised to power x plus 27 all equal to 0. So in order to solve this, we are going to let t be equal to 3 raised to power x. So when this happens, we are going to substitute anywhere we see 3 raised to power x, we are going to put t. So here we have t squared minus, we have 12 here, and we can also find 3 raised to power x here. So you write t plus 27 all equal to 0. As you can see, we have here a quadratic equation. So we are going to solve this quadratic equation using factorization method. So in factorization method, you are looking for two numbers such that when you add them, you have minus 12, and when you multiply the same number, you're going to get 27. So let us do the experiment here, somewhere here. I'll take minus 3 times 9. Okay, minus 3 times minus 9 will give us plus 27, yes. But when you add these two numbers, is it going to give us 12? Is it going to give us minus 12? The answer is yes. So we are going to use this very one here. All right, we are going to use this. So we write everything here. T squared minus this very one now, minus 3t minus 9t, all right, plus 27 all equal to 0. So the next step here is to group them in twos. So we are going to group these two and also this other one. So we take the common factor here. Common factor here is t, into t squared divided by t is t, minus 3t divided by t is minus 3. You are done with this side, you move to this other side. So the common factor here is minus 9. You open the bracket, minus 9t divided by minus 9, the answer is t. 27 plus 27 divided by minus 9, the answer is 3. You close the bracket, all equal to 0. Okay, so we are going to pick this, and also since this one are the same, you pick one of them. So you are going to have t minus 3 equal to 0, or t minus 9 equal to 0. So it is either this one is 0 or this one is 0. By the time you add t, you add 3 to both sides, you have 3 here, or if you add 9 to both sides, you are going to get t equal to plus 9. Okay, and mind you, what you have here, okay, remember our t is equal to 3 raised to power x, and the answer here is t equal to 3. So we are going to substitute back these values here into this very place. So when you do that, for this first one here, we have 3 raised to power x equal to 3, and you know that this will give us 3 is the same as 3 raised to power minus 1, or in this other side, substitute this value here, you have 3 raised to power x equal to 9. So to get the same base in this very one, you're going to write 3x all equal to 3 raised to power 2, because 3 raised to power 2 is same thing as as 9. Okay, so from here, our first x here is equal to 1. Since the bases are the same, cancel out. And the second x here, since the bases here are the same, x here is going to be equal to 2. So we have the equation here, this very equation. So the equation has two solutions, that is x1 equal to 1, and the second one, s2 is equal to 2. So this is the answer to our problem. Follow for more.